Hello, this is Andrea Hendricks. The topic of this video is multiple angle formulas. Specifically, we're going to talk about double angle formulas, and then we're going to use those to find trig values and also use those to verify identities. The double angle formulas actually follow from the sum formulas that we've already discussed. For instance, if we want to find the formula for cosine of 2u, you're going to look at that as the cosine of u plus u. Recall that the cosine of u plus v was cosine u cosine v minus sine u sine v. So whenever we replace the v with another u, we get cosine u minus sine u times sine u. So therefore our formula is cosine squared u minus sine squared u. Now the other two are just different variations of that whenever we use the Pythagorean identity, cosine squared u plus sine squared u equals 1. Remember that we can solve for sine squared u to get 1 minus cosine squared u. Likewise, we can also rewrite cosine squared u as 1 minus sine squared u. So whenever we replace either cosine squared u with 1 minus sine squared u, we would get this formula 1 minus 2 sine squared u. If we replace sine squared u with 1 minus cosine squared u, we get another iteration, which is 2 cosine squared u minus 1. Now, the formula for sine of 2u follows from sine of u plus v. And recall that formula was sine u cosine v plus cosine u times sine v. So likewise, if we make a replacement with the v of another u, we get the formula sine u cosine u plus cosine u times sine u. Well, those two expressions are identical, right? They're like terms, so we can combine them to get 2 sine u cosine u. And then the last formula follows from tangent of u plus v. Recall that formula was tan u plus tan v divided by 1 minus their product. So replacing the v with another u, we get 2 tan u over 1 minus tan squared u. Okay? So now we can talk about how to use these formulas to find certain trig values. Here we have an example. We want to use the double angle formulas to find sine of 120 degrees. Now, I know that you can use your unit circle and find sine of 120 degrees, and that's fine. I just want to show you how you would get the same result if you happen to use the double angle formula. So sine of 120 degrees, we can rewrite that as sine of 2 times 60 degrees, and then apply that double angle formula, which was 2 times sine u cosine u. So we get 2 times sine of 60 degrees times cosine of 60 degrees. Well, the sine of 60 degrees is the square root of 3 over 2, and the cosine of 60 is 1/2. So whenever we look at that, we get a common factor of a 2 that can divide out, and so therefore we get a result of the square root of 3 over 2, which is exactly what you would see if you had that on the unit circle. Now let's look at another example that's a little bit more involved. Here we want to find sine of 2u, cosine 2u, and also tangent of 2u if we know that sine of u is -4/5 and we're told that u is in between 3 pi over 2 and 2 pi. So this information is important to tell us what signs we need to use. If u is in between 3 pi over 2 and 2 pi, that tells us that u is actually in quadrant 4. So we know that quadrant 4 has coordinates that are positive and negative, so therefore cosine is positive and sine is negative there. So we've got to find, first off, cosine u by using the Pythagorean identity, sine squared u plus cosine squared u equals 1. And we've done that part many times over. So if we plug in there, we would get sine squared u plus cosine squared u equals 1. Plugging in the information that we were given, which is sine u is negative 4/5. So we can square that and get 16/25 plus cosine squared u equals 1. And now it's just a matter of solving for cosine. We subtract 16 over 25 and recall that 1 is really what? Yeah, this is really 25 over 25 minus 16 over 25, and so we get 9 over 25. And then if we apply the square root property, we get cosine u is plus or minus the square root of 9 over 25, which is 3 over 5. But we can't have both signs, but from what we just talked about earlier, we know that cosine is positive since u is in quadrant 4. So the value of cosine u is 3/5. Now we know what sine u is. It was negative 4/5. We know what cosine u is 3/5. So now we can find the sine of 2u, cosine of 2u, or tangent of 2u. The sine of 2u is 2 sine u cosine u. So we're making the appropriate substitutions. 2 times negative 4/5 times 3/5. Multiplying those out gives us a negative 24 over 25. Right, from this point on it's just a matter of plugging into the formula, so really nothing to do. Cosine of 2u is cosine squared u minus sine squared u. So we would have 3/5 squared minus a negative 4/5 squared, which is 9 over 25 minus 16 over 25, and that reduces to negative 7 over 25. Tangent of 2u, there's actually two ways to do that particular problem. We can divide sine of 2u by cosine of 2u, and that's actually the quickest way to do it. We would get negative 24/25 divided by negative 7/25 multiplied by the reciprocal, so that's really negative 24 over 25 times negative 25 over 7, and the 25's divide out, leaving us with a positive 24/7. The other way to do it is to plug on, and I didn't show you here, plug into the tangent of 2u formula. So you could do 2 times tangent of u divided by 1 minus tan squared of u. To do that particular iteration, you have to find out what tangent of u is. And so to find out what tangent of u is, you would have to divide sine u by cosine u to figure out what that value is and plug in. So that's going to be a lot more tedious to do. If you already know sine of 2u and cosine of 2u, just divide them to get the tangent value. Now, just looking at this, we know that angle u is in quadrant 4, so thinking about, well, where does 2 times u lie? And 2 times u we know is going to lie in quadrant 3. The reason we know that is that the sine is negative and the cosine is negative. So when both coordinates are negative, that is in quadrant 3. So just to kind of visualize what we're talking about here. If we have an angle that's in quadrant 4, let's say maybe 300 degrees, what is 2 times that angle? It would be 600 degrees. So you're thinking about, well, where does 600 degrees lie? And I'm not saying that's the angle that u is. Actually, to find u and 2 times u exactly, you could use the inverse function to figure out what angle we're talking about, and then actually truly check to see what angle 2u is, but just to kind of give you a visualization of what 2u actually means. Now let's do another example, very similar. The only difference is the information that we were given changes just a bit. So this time we want to find sine 2u, cosine 2u, and tangent of 2u if we're given that secant of u is -3, and we're also told that u is between pi over 2 and pi. So knowing that u is between pi over 2 and pi tells us that u is in quadrant 2, right? So that tells us that cosine is negative and sine is positive in that quadrant. Well, we have to figure out what cosine and sine values are before we can plug into the formulas. If we are told that secant of u is -3, we know that secant is a reciprocal of cosine, so therefore cosine of u is -1/3. And then we're going to do the same thing that we just did in the previous problem. We're going to use the Pythagorean identity to figure out what our value of sine is. So we know sine squared plus cosine squared is 1. Replacing cosine with -1/3 and squaring gives us sine squared u plus 1/9 is equal to 1. We can solve for sine squared by subtracting the 1/9. And recall that 1 is really the same thing as what? Yeah, it is 9 ninths over, I'm sorry, 9 ninths minus 1 ninth. We subtract those to get 8 ninths. So sine u is plus or minus the square root of 8 over 9, which is the square root of 8 over 3. But because we know it's in quadrant 2, we're going to stick with the positive value for sine of u. Now we just use the appropriate formula and plug in. So our sine of 2u is 2 sine u cosine u. So 2 times the square root of 8 over 3 times -1/3. Multiplying the numerators and denominators gives us -2 on the square root of 8 over 9. And then you can simplify the square root of 8 to be 4 times 2, which is really 2 on the square root of 2, times that coefficient of 2 is 4 on the square root of 2 over 9. Cosine of 2u is cosine squared minus sine squared. So we have a -1/3 squared minus the square root of 8 over 3 squared. Okay. So remember what we're plugging in for sine squared u. We're not plugging in sine of 2u for that. We're plugging in sine of u. So go back to where we found sine of u. That gives us, when we square, 1/9 minus 8 over 9, which is a -7 over 9. And tangent of 2u, again we can divide sine by cosine, and when we do that we multiply by the reciprocal to get 4 on the square root of 2 over 7. So here again is an example of an angle 2u that is in which quadrant? Well, sine and cosine are both negative, so the angle 2u would also be in quadrant 3. Okay. Now let's look at the next objective, which is to verify identities using the double angle formulas. And these double angle formulas you don't have to have memorized. You're going to be able to use them on a formula sheet for the final exam, but you should be able to apply them certainly. So if we want to verify that cosine of 2u is, cosecant of 2u is cosecant u times secant u over 2. Well, we're going to start with applying the double angle formula and see if we can work from there. We know cosecant of 2u is the reciprocal of sine of 2u. So we begin by saying that cosecant of 2u is 1 over sine of 2u. And then we're going to replace sine of 2u with the formula that we just learned, 2 times sine u times cosine u. Well, then we can split that fraction up to be really 1/2 times 1 over sine u times 1 over cosine u. Well, 1 over sine u is cosecant u, 1 over cosine u is secant u. So when we have 1/2 times cosecant times secant, we get exactly what we needed to show. So we're done with that one. And then the last example, verify secant of 2u is secant squared u over 2 minus secant squared u. There's several ways to approach this problem, but the first thing I did is to recall that secant squared u is 1 over cosine squared u divided by 2 minus secant squared u would be 2 minus 1 over cosine squared u. So I'm using the reciprocal identity first, and then I'm going to clear the complex fraction. Okay? And remember, to clear the complex fraction, you can multiply the numerator and denominator by the LCD. And the LCD of this complex fraction is cosine squared u. So we're going to multiply the numerator by that and the denominator by that. So multiplying in the numerator, cosine squared u times 1 over cosine squared u is just simply 1. In the denominator, we have to distribute cosine squared u to the 2, so that gives us 2 cosine squared u, and then cosine squared u times 1 over cosine squared u would give us minus 1. Well then, if you recall from the double angle formulas, 2 cosine squared u minus 1 is a variation of cosine of 2u. So that gives us exactly what we need to show, that 1 over 2 cosine squared u minus 1 is equivalent to 1 over cosine of 2u, which is the reciprocal of secant. So we have secant of 2u, which is exactly what we wanted to show there. So if you have any questions on using the double angle formulas, please don't hesitate to contact me. Excuse me, your book does talk about a lot of other formulas. Half angle formulas you may want to glance over, and if you had to use those in calculus, it's basically, again, just given that formula and being able to use it. You can look at the derivation of that in the textbook if you like. There's product to some formulas, those things, but you don't have to use those in this course. But just be aware that there are a lot of other formulas that we can use with these trig functions. Okay? Thanks.